So we are going to start with implement CICD with GitHub Actions and infrastructure as a code with Bicep. So let's start with the prerequisites. Let's first prepare the Azure subscription for the lab, and then we will start with modifying the Bicep template. So I'm logged in as user 1 in this account, and I have a subscription in this lab environment given. So we are first going to configure the Microsoft Cloud Shell. So here first we are going to select, or uh, before we can configure that, we have to make sure our resource provider for this subscription, that is Microsoft Cloud Shell, is registered. So I'm going to search for here Microsoft.Cloud Shell, and we can see that it is not registered. So let's click on that and register it, because we need to work with Microsoft Cloud Shell. Now once this is completed, we'll just start with the exercise 1, which is implementing infrastructure as a code and CICD with GitHub Actions and a Bicep template. So there are 3 tasks. Task number 1 is fork and review the GitHub repository containing the source code of a web app, a GitHub Actions workflow, and a Bicep template. And task 2 will be to configure the target environment, which is web app service. And the task number 3 is to validate the infrastructure as a code and CI/CD functionality. So let's start with task number 1. We are going to fork and review the GitHub repository containing the source code of a web application, a GitHub Actions workflow, and a Bicep template. So let's navigate to the GitHub sample repository, which hosts the .NET version of a sample website. So here it is, and we are going to make sure that we sign in into the GitHub account. Let me complete the two-factor authentication. Once this is completed, we are going to fork this repository. So here we have this option, create a new fork. Okay, so we already have this repository over here, and we'll just go to the forked repository. You can see that source is mentioned over here. So you have this main branch. We are on the main branch of the repository. There are GitHub workflows, infra directory, which will contain the Bicep template named webapp.bicep, source web directory, which contains the .NET core of the source web app. So let's open the GitHub workflow, and here we are going to view the YAML content, eShop and web CICD.YAML, which contains the build and test and deploy jobs, which consist of the following tests that you can like these are the some steps, okay, that it contains. It will check out the repository, prepare the runner for the desired .NET version, build, test, and publish the .NET project, upload the published website code artifacts, upload the bicep template as an artifact for the next job. So here we do not need to focus on details of each job. It is important to understand the purpose of the workflow, right? It is going to deploy a web app to Azure Web App Service. So here the process of provisioning Azure resources, which will target a resource group, RG eShop on web. Okay, that's web West Europe. Okay, and we also need like the workflow relies on a secret to authenticate to the target Azure subscription, which is over here. Azure credentials, secrets.azure credentials. So you need to set up the secret before you run the workflow. And this is the syntax, like the workflow is going to be triggered manually on workflow dispatch. Okay, so let's go to Azure portal, and here we will check for the resource groups in this subscription. So we have RG DevOps Foundation, RG eShop Web East US 2, and RG Shop on Web West Europe. Okay, so all the resource groups are created for you. You just have to provide the name, and you have to select the data center, and you have to like you can also add a metadata if you want, like a tag. Then we open Cloud Shell, we switch to Bash, and here for this no storage account required, so let's select only the subscription. Let Microsoft create a storage account which will persist the session files. Okay, let us change the reason. No storage account required, and yeah, so we are going to retrieve the value of the subscription ID in a variable. And if we try to print the variable value, this is the variable value, subscription ID. So let's make a note of it in a notepad. That's my subscription ID. And we have to create a service principal for the resource deployment in the Azure environment, and we have to assign the role of the contributor for that service principal. Okay, so let's create one. And we have to copy this value as well, because this we are going to use as a secret. The entire JSON output we have to record it, and we have to go to GitHub. Here we just select settings, secrets, actions, And here we are going to define over here, let's update this. So here I'm going to give that JSON value. Now this secret is updated. Okay, and this will be used in the YAML file. Now we are going to validate the infrastructure as a code and CICD functionality. So let's go to the code tab. We have to make sure that we are on the main branch, and we need to go to the GitHub workflows, selecting the YAML file, and we will make some changes over here. This is already on workflow dispatch, which is a trigger, manual trigger. Okay, you have to make sure you are using proper indentation. Resource group West Europe, then location is equal to West Europe. Here the template ID infra webapp.bicep, and you have to replace our subscription ID over here with this value that we have recorded. Okay, I think we have to use edit option, and here we go. That's our subscription file. Subscription ID that we have already mentioned. The web app name is DevOps Web App West Europe. This will be the name of the web app, and let us check everything is proper. Yes, that's all. Need to do these changes, and now we are good to go. Commit the changes. Commit directly to the main branch. Now let's again go to the code, check the bicep file, which is webapp.bicep, this one. Okay, you have to make sure you have selected the service plan, then name, location, it's going to get app service plan ID. Okay, so everything is proper in the bicep. Okay, now let's go to actions. We are going to run this uh, build and test workflow. Now it will give all the results over here, the workflow, whether it is successful, completed. Okay, and it's going to complete the next pages also, like build and test, and then it is going to go to the deploy phase. So this deployment job is completed, and now we will go and deploy another web app services. So for the second web app services, we have to make some changes in the workflow file. So here we will make some changes in the workflow file. Click on edit, and this section we are going to replace with another region. So this application will be in East US 2, then location will be East US 2. Now and we will change the location as East US 2. We will replace the web app name as well. So here we need to give some another name that will be used for the second application that is deployed in the East US 2. Commit changes. Now let's go to actions and run this workflow. So now this workflow has started, and this is going to deploy the second application over here in this East US 2 resource group. So let's wait for that to complete. So in the previous lab, we deployed two instances of .NET Web App Service into Azure region, one in the West US, West Europe, and the second one in the East US too. So we have the East US instance too ready as well. Now we are going to learn how to enhance the workload resiliency by using a traffic manager. And we are going to test the resiliency using a service called as Azure Chow Studio. So let's start. Subscriptions, and you need to make sure the resource provider for Microsoft Chows should be registered. Let this complete. It's going to take 2-3 minutes, and till then we are just going to deploy a traffic manager profile, create, and you select the resource group over here, RG DevOps Foundations, and make sure the name of this, let me enter DevOps Foundations profile. You can mention any name, but here in the lab it has policies, so I'm selecting the default that is given. Priority method you can select from weighted, geographic, multi-value, subnet. I'm going to select priority. Once this is created, we are going to add two applications that we have deployed. Need to do some settings. So our traffic manager profile is ready, and so we have these options over here. Status is enabled, routing method is priority, right? You can see the properties. This DNS name is going to be required, so let's copy it over here in the notepad. Okay, now we will change the time of time to live, DNS time to live, which is set to 60 seconds, and we will make it 5, because lowering the value of time to live will accelerate the failover time, right? And in addition to the value of the time to live, probing interval, probe timeout, and the tolerated number of failures, okay, right here you can see, will be affecting the amount of time that an endpoint failure is detected. So we will make sure protocol is HTTPS, port 443 for HTTPS, and as both of the Azure app services will be configured as endpoints, and they will be accessible via the HTTPS port on the default TCP port 443. Let's save this configuration, and now we are going to add the endpoints. Now here we will add the first endpoint, okay, with whether it is an Azure endpoint, external, or if you have an external web application or a nested endpoint. Right, so mine is a web app service, and I'm going to give the name as East2S2 for the first app. Enable endpoint, make sure this is selected, and my service is an app service. It can be an app service slot deployment or a public IP address if you are using your own app service or any cloud service, right? You can also try for the cloud services. Now here we're going to select this web app service instance, and let's keep the priority as 1. A lower priority will designate a higher precedence, and in this case all the requests will be sent to the web app instance in the East2S2 as long as that instance remain available. Make sure health checks are enabled, and the rest target resource priority, okay. If you want to add the custom header settings, you can add it, but this required in case if you're using a custom header settings. Let's add another endpoint. Again, I'm going to add the name of this endpoint as Web App Europe, West Europe. App service endpoint enabled priority 2, and we need to select the name of the West Europe instance. So these are our 2 endpoints, and now we are going to test the traffic manager functionality. So the DNS name which is given for an application for our service, it will be displaying the page of the website, which is eShop on web, hosted by our web app services that we have deployed in the previous lab. Now back to our Azure portal, let's prepare the failure. So we are going to we are going to give the command to resolve the DNS name of the traffic manager profile that we have created in the previous task. So that will be like this. So here in place of a TM profile, we are going to add the DNS name and copy this. It's going to give the Okay, so this is added. It's giving the address, and now it's giving us the details over here. Like that's it will reference the DNS name of the web application in the East US 2, right over here. You can rerun this again to get the, yeah, this is the DNS name, and the canonical name is that it references is an instance of the web app 2 right now, right? Now we are going to test the workload resiliency by using the Azure Chow Studio. The purpose of the Chow Studio is to assist with measuring, understanding, and building application and service resilience. And this is accomplished by intentionally disrupting workloads in order to identify resiliency gaps and implement corresponding mitigation proactively rather than reactively. So let's search for Chow Studio, and here we are going to add our targets. So you can see the Azure App Service web app instances are visible, right? Now here we will select it and enable the targets, service direct targets. Okay, let me cancel this and go back to Chow Studio targets. We need to enable target only for East US 2 instance, and we will implement experiment in the next step once it is enabled. This will take less than a minute. So now I can see that it is enabled. Okay, let's go back to Chow Studio under experiments. Now here in the targets, if you see, if you refresh it, this okay, both the experiments, we will create a new experiment. If you can also create it from a template. Subscription resource group, and let's add the name of, that is, it's our DevOps Foundation Labs experiment 1, and this one we are going to experiment with a West Europe instance, right? So we can choose any region over here, but considering that we are testing failure to a resource in the West Europe, any region other than East US2 seems more appropriate. So let's select that. So these are the steps over here. Basics, we have selected the name, permissions, you can assign a system assigned identity, you can leave it as it is. And now here we need to give the name of the steps. Let's say step 1 will be failover and web app service, and here you need to select emulate an app service failure. So this is the steps that are going to get carried when you experiment. Now add action, you are going to add the fault over here in the add action section, and in the fault details we need to mention, okay, what to do with that application. Stop the app service, you want to test network latency, network disconnect, kill process, right? So what you are doing testing with, so we are selecting like what will happen when the app service stops, and duration minutes we will leave it as it is 10. Now you need to select what is your target resources over here, right? And we will select this one, uh, which we selected as a target resource. Let's create it. We need to also grant the newly created managed service account permissions enough to stop the Azure App Service web app. And we will use the Azure contributor role. You can also create a custom role if you want to follow the principle of least privilege. Okay, let me check what's missing over here. Yeah. Let's go to that app service instance of EaseJS2, and here we will add the permissions on the system assigned identity. So Azure contributor role, and here we will select the managed identity that we created, choose experiment, and select. Right, so this is, we are assigning the permissions of an Azure contributor on the chows experiment resource. Now we will validate the experiment. So let's go back to the chow studio, experiment, and select this, and we will start. You can see under the settings your experiment permissions that we have assigned, right? Start this experiment. We have to wait until the status of this changes to running. Pre-processing now. Here you can see all the experiment details. It will you can just review the lists containing the step, the branch, and the action associated with the experiment over here. Now it's changed to running state. You can check it in the details section, all the steps that you have included in your experiment. We can check, right, fault details, the running targets, which is a West Europe instance. So which means your instance is running. Okay, and you can see that this instance has stopped. Now let's verify whether the traffic manager is successfully redirecting the request, targeting its profile to the endpoint representing the app service web app in the West US region, right? So let's open a new browser page, and here we can copy the DNS name again and paste it. Okay, it shows the web page which is familiar to the website hosted by the Azure App Service. Okay, now let's go back to the Cloud Shell. Again, we can perform an NS lookup. Let me copy it again. Okay, now it's copied. Here we'll make some changes. Let's go back to the Java Studio. Experiments, will add this. We will change the target over here. Experiments. Okay. So here we have selected the instance as East Europe, West Europe, and that's why it stopped that instance. Instead of that, we are going to select the target as East US over here. And now this one will be stopped. Saving it. Stop the experiment. Now let's check which instance is stopped. It should stop the East US2. Okay, it is running. Let's go back. Okay, let's do one thing. Let's delete this or try to stop and restart it because we have made the changes. Okay, let's start it again. Okay, start it again, and this should stop the web app service instance of East US2. It should stop this one. Yes. So now that's stopped, and let's check whether the web apps service is still running when we have one of the endpoints down, the priority one endpoint down. So the primary objective of the exercise was to illustrate the process of implementing Azure Chow Studio base testing and its primary components. You would use the equivalent approach if an Azure App Service web app was a part of more complex environment where the impact of its failure must be more challenging to predict. Right. So this instance now is running, and the other instance that we have tested with the East US2 is stopped using the Chow Studio. So that's all about this lab, how we have tested the workload resiliency by using a traffic manager. Here, this is your traffic manager profile. Here you can see which endpoint is right. So here it is balancing the load. It's load balancing uh, with the load balancing functionality of a traffic manager between these two web app instances. And we have just used the Azure Chow Studio to trigger a failure of one of the applications to test the resiliency of the load balancing implementation. Right.